Hello everyone. Yeah, we'll start the session soon. The session is timed from 6 p.m. to 8 p.m. And since not many people have joined, let's wait for 5 more minutes, 5 to 10 more minutes, and we'll then uh, start the session.
All right, we have almost six attendees by now. We'll wait for 2 more minutes before we start the session. In case you are in contact with the other attendees of the session or other participants of the course, you may inform them so that they can join the session. I hope that the link has already been shared with you. All right, let's get started. Uh, I hope my screen is visible. Can somebody respond in the chat? Can somebody respond in the chat if my screen is visible or not? We would encourage to keep this session interactive. So, since you all are muted, the use of chat is increased. And as and when you guys raise your hands, I'll unmute you and you guys can ask your questions. I'm waiting for your go ahead. Okay, Dr. Satish has raised his hand. I'll allow his mic.
Dr. Satish, you can unmute yourself and say, I'm not able to hear you. I'll also allow mic for Shivam Talwari. I'm not able to hear Dr. Satish. Shivam, can you speak? Yeah.
Yes, sir. Yes, sir.
Is my screen visible?
Yes, sir. Yes, sir.
Okay. And whenever I'm changing the lectures, I'm changing the slides. It is also working? Fine.
Yes, sir. Yeah.
And I'm audible, right?
Okay. Yes, sir.
Okay. Thank you. Let's get started. Hello everyone, I am Ashirvad Satpathy. I am a PMRF research scholar at IIT Delhi in the Department of Civil Engineering. My PMRF ID is shown in this slide, and I am the teaching assistant for the NPTEL course titled Maintenance and Repair of Concrete Structures, which is taken by Professor Radhakrishna G. Pillai of IIT Madras. And this is a weekly discussion and doubt clearing session. So these kind of sessions we'll be having every week. And so there is another TA who is also taking another session every week. That is on Friday from 7 to 9 p.m. on every Friday. And my session will be on Saturdays from 6 to 8 p.m. And as I have already told you, the link of these lectures will remain same. So it has already been mailed to you, and you guys can log into the meeting. So the meeting link will remain same for the time for the duration of this course, and you guys can log into that meeting, and we'll be having weekly discussion and doubt clearing sessions. I'll also like to tell you that in case you miss some of the sessions, these lecture sessions will be uploaded on YouTube, the link of which will be shared to you in the next week. And so, in case you miss some of the sessions, or you want to go back and see some of the questions or practice assignment, whatever we are discussing during the sessions, you can go and check out the YouTube videos. In today's session, the agenda for this meeting is going to be, first of all, since the week one assignment that has been given to you, the deadline for submission of that assignment is, I guess, 8th of February. So we will not be discussing that assignment today because I mean, you guys have to first submit your assignment before, and after that only we'll be able to discuss the assignment questions. So in this session, I'll be discussing the practice assignment 0 that has been given on the SWAYAM NPTEL portal, which is just to test the basics of civil engineering or concrete and durability issues related to concrete. And at the end of the session, I'll try to clarify the doubts that you might be having related to the week one lectures that have been already uploaded, not the week two and week three lectures. The doubts of those lectures will be taken up in the upcoming sessions, in the upcoming weekly sessions. In this current session of today, we'll be taking the doubts of the week one lectures. All right. So this is the first question of the practice assignment 0. In concrete, the primary purpose of cement is to fill the space between aggregates, bind the aggregates, protect the aggregates from chemical attack. All of the other choices, none of the given choices. I'll uh, I'll go to the meeting and check if you guys want to answer this question. And if you guys want to answer some of these questions, you will also have to tell the reason why do you think that is the answer. I Okay, Shailendra Yadav has raised his hand. Yeah, you can raise your hand so that I'll allow your mic and you can answer that question. I'm allowing the mic for Shailendra Yadav.
Thank you, sir.
Yes.
The answer for this question will be in concrete primary purpose of cement is to bind the aggregates.
Okay. And why the other options are not correct? Can you discuss that as well?
Because sir, we cannot use only cement to use to fill the space between aggregates and
Okay.
protect the aggregate from the chemical attack. We can use, but not for only for the product, not only to protect from the chemical attacks.
Right.
So these are we can use, but not at a more level. But binding of the aggregate is the main purpose of the cement.
Right. Right. Correct. Okay. Thank you, Shailendra. Shivam has raised his hand. Shivam, do you want to answer this question? You can unmute yourself and answer. Okay, Shivam doesn't want to answer this question. Shailendra, you can. Yeah, yeah. Dr. Satish is raising his hand. Yes, Dr. Satish, I have allowed your mic. Dr. Satish, I am not able to hear you actually. I guess you have some issue with your headphone or microphone or whatever. You might try reconnecting your headphone, or you might try logging into the meeting again. You can leave the meeting and log in again. Sure. Thank you, sir. Okay. So, yeah, as Shailendra has already answered um, the question correctly, the primary purpose of cement is to bind the aggregates. So filling the space, I mean, in concrete, not only cement is present, we add fine aggregates, we add several SCMs. So filling the space is not the primary purpose of the cement, nor is it to protect the aggregates from chemical attack, because even if we add cement to the concrete, it doesn't guarantee protection of aggregates from any kind of chemical attack. So the correct answer is um, bind the aggregates. The primary purpose of cement is to bind the aggregates. We'll go to the next question. The second question was decreasing the water content in concrete and use of superplasticizers can ensure more compact and durable concrete provided the proportion of all other ingredients remains same. True or false? Does anybody want to answer this question? Okay, Srinivas has raised his hand. Okay, you have to raise your hand in the meeting so that I'll be able to see. Yes, Srinivas, I have I have allowed your mic. You can answer this question. You can unmute yourself and answer. It's not audible, Mr. Srinivas. You have to unmute yourself and answer. Yes.
Am I audible?
Yeah, yeah, it is
Yeah,
audible.
yeah. Yeah, I think it is true, sir, because by using the superclassifier, we can decrease the water content, so which gives you
Right.
more durable concretes.
And why
And
do you
this
think decreasing the water content is going to give us a more durable concrete, sir?
yes, sir, because voids will be lesser and concrete will be more compact, and as we know, water cement ratio of 0.38 and below that will give us a durable concrete. So anything above zero point 0.4 voids are bound to come, sir, and which will affect the durability.
Yeah, right. You're partially correct. Even if the water to cement ratio is below 0.38, then also the voids are going to come inside the concrete. But relatively, I mean, in comparison to other higher water to cement ratios, the void proportion is going to be lesser than that than in is going to be lesser in the lower water to cement ratio concretes, right?
Yes.
Okay. And I want to add an additional question to this. In this question, it has been given that in the last line, it has mentioned that provided the proportion of all other ingredients remains same. do you want to shed some light on this? Why do we want, I mean, when we are comparing two concretes with one with a high water content and one with a reduced water content and use of superplasticizer, why they have mentioned provided all other ingredients remain the same?
Okay, in this case, even if water also remains the same, uh, uh, I think
Mhm.
like that, sir. If the water content also remains the same like that, decreasing the water content is mentioned.
Well,
Other terms,
let's not talk just about water content alone.
okay.
What other if they've told that keeping all the other ingredients same, apart from water and superplasticizer, keeping all other ingredients same. So, do you think that other ingredients also affect the durability of concrete and how? Okay, I'll allow the mic for Shailendra. I guess I'll give the first chance to Dr. Satish again if he's able to unmute and speak. Dr. Satish, I have allowed your mic. You're still not audible, Dr. Satish.
Are are you able to
Yeah,
hear me
yeah, yeah,
now?
yeah. Right, right. Yeah. Now I can.
Okay, okay. Right. Because other ingredients are more or less neutral, inert role they have. So they are not likely to affect durability to a large extent. They may have some marginal effect only.
Okay, okay. I agree. Not exactly all other ingredients are inert because there might be reactive aggregates as well. But
That's right, that's right. In
but
general,
yeah, right. In general, okay. But
yeah.
keeping the proportion of all, why do we want? I mean, let's say if we alter the proportion of sand in the concrete, will it affect the durability? The proportion of finer materials in the concrete, will it affect the durability?
Not appreciably.
Not appreciably. Okay.
There may be marginal difference, but not appreciable difference.
Okay. Okay. Does somebody else want to answer this question? Thank you, Dr. Satish, and thank you,
Okay.
Mr. Srinivas. Shailendra has raised his hand. Yes, Shailendra, you can unmute
Yes,
yourself.
sir. I want to say that either there are many of the ingredients present in the concrete other than the water and superplasticizer,
Right.
that is cement, sand, etc. Cement has also many reactive chemical components. But in the light of this question, it is given for only to compare in the water content and superplasticizer.
Right.
The main focus of this question is to compare between water content and superplasticizer, and keeping the proportion of all the ingredients remain same. It helps us not to go on the other ingredients. We have to consider only the water and superplasticizer, and what will be the effect of this. We have to only consider.
Right. Right. Thank you. Thank you, Shailendra. So, yes, it is true. Decreasing the water content in concrete and use of surplus razor can ensure more compact and durable concrete because, as Mr. Srinivas has already mentioned, the voids are going to be lesser, and that will give us a more compact pore structure, which will increase the durability of concrete. And as Shailendra and Dr. Satish have also highlighted that the proportion of all other ingredients have to remain same in order to compare both the water content in case of with and without use of superplasticizers because other ingredients in concrete also participate um, in framing the microstructure in developing the microstructure. So let's say we increase the cement content, it is going to affect the durability because it is going to affect the pore structure. Let's say we alter the finer material content, the fine aggregates content, or we alter the content of supplementary cementitious materials in the concrete, then also it is going to affect the durability. So keeping all other ingredients same, if we just want to compare the water content with and without the use of superplasticizer, then with using the superplasticizer, it will better the durability of the concrete. So this is true. Now we'll move to the third question. The third question was incorporation of supplementary cementitious materials such as fly ash, slag, metacolin, rice husk ash, bagasse ash, silica fume, calcined clay, etc. can enhance the durability of concrete provided the curing is done adequately. I'll also again highlight the last line of this question. Provided the curing is done adequately, true or false? Can somebody answer this question? And I guess this is more or less related to what we discussed in the last question. Okay, Mr. Srinivas is raising his hand. I would like for someone else to answer to this question. I'll give you a chance if nobody else answers to this question. Okay, Venki has raised his hand. I'll allow him first. Yeah, Venki, you can unmute yourself and speak. Venki, am I audible to you? You can unmute yourself and answer the question. Venki, you are muted. You have to unmute yourself and speak. Okay, let's move to Venki. We can't hear you, so try unmuting yourself. We'll move to Mr. Srinivas again. He has raised his hand. Yes, Mr. Srinivas, you can unmute yourself and speak. You're muted.
Yes. Yes, sir. Definitely, the cementitious materials are going to improve the durability, sir, provided there is adequate curing because of the secondary gel formation. In the presence of cement, calcium hydroxide will be formed as a byproduct, and these cementitious materials will use the calcium hydroxide, and again secondary gel formation will take place, sir, and pore refinement will also take place. So as a result, the permeability will be reduced, and the concrete will become more durable.
Great, great. Thank you. Thank you so much. You have covered almost all the points, but thank you for your answer. But I'll also again like to highlight that last part of the question. Why do they want uh, that the curing be done properly in case of incorporation of supplementary cementitious materials? Can you shed some light upon that?
Yes, sir. Because of, for the secondary hydration, water requirement is there, sir. For the formation of calcium, CSH gel, like calcium silicate hydrates, presence of water is very important. That's why even in the code also, for blended cements and all, they have given a 10 days minimum period of curing when compared to OPC.
Okay.
Uh,
Is it only
so
about
the
is it only about the water requirement, or is it has it some does it have some relation with the age or with the aging of concrete, with the duration of curing?
Yes, sir. The duration of curing improves whatever water we have added during hydration that will be available for the concrete to hydrate, and thereby that internal structure will keep on improving, sir, as long as we provide the curing.
Okay, thank you, Mr. Srinivas. Anybody else wants to take a answer to this question? Dr. Satish. Okay. Yes, Dr. Satish.
Whatever Mr. Srinivasan had told, I agree with that. Then generally these particles are very fine, so surface area is likely to be more. So requirement of water increases. So proper curing is a must. Without which we cannot get the benefit whatever we desire.
Right. Okay. Thank you. Yeah, so as both of them have rightly pointed out, incorporation of supplementary cementitious materials. First of all, these materials are finer materials, so they kind of fill the voids in the concrete microstructure, the matrix. Secondly, these supplementary cementitious materials are pozzolanic in nature, so they react with the hydration product, that is calcium hydroxide from the cement hydration, and they react with that to form the secondary gel that already they have the secondary CSH gel that they have already pointed out. So that is an additional hydration product that is being formed apart from the cement hydration. So the pore structure is refined by that, and the permeability or the transport properties are improved, the permeability is reduced, the pore connectivity is reduced by that. And regarding the last part of this question, which is provided the curing is done adequately, because the nature of these cementitious materials is such that they react slower than the cement. So the curing has to be done for also, of course, there is additional requirement of the water, but the curing has to be done for a longer duration so that these materials get sufficient time to, to react with the calcium hydroxide, because as the calcium hydroxide gets consumed, there must be water present in the cement pores for this unhydrated cement particles to get hydrated and thereby produce additional, more calcium hydroxide, which in turn gets reacted with this supplementary cementitious material. So these SCMs take a longer duration to contribute to the strength and durability of concrete. So yeah, the answer to this question is anyway, it is true. Okay. The coefficient of thermal expansion, the fourth question is the coefficient of thermal expansion of concrete and steel are similar in range. Also, the highly alkaline nature of concrete helps in preventing corrosion of embedded steel reinforcement. Can somebody answer to this question? Is it true or false? These are the usual people. Anybody else, other attendees, except from Dr. Satish, Shailendra, Mr. Srinivas? Anybody else who wants to take? Okay, Venki, I'm allowing your mic, but you need to unmute to speak. Venki, can you unmute yourself and speak? Okay, okay, anybody else? Anil, Kiran, Manisha, Quadri? No? Okay, let's go to Shailendra again. Yes, Shailendra, you can unmute yourself and speak.
Yes, sir. Thank you, sir. Sir, actually, this is the property of steel. We have chosen to work with concrete. These are the main property, that is the thermal coefficient of thermal expansion and the highly alkaline and the prevention of corrosion of the embedded steel with the help of concrete. These both are property of concrete and the property of steel help mixed together to stay strong. That means that this is a property of steel which used for the with the concrete, and the property of concrete is and that is to prevent for preventive corrosion, which is for the with the steel reinforcement. And this is true overall, sir.
Okay, thank you. Uh, Dr. Satish has raised his hand again. Yes, Dr. Satish.
Yes, we require alkaline of concrete to prevent corrosion. Formation of a passive film. It is a must. We have value of the order of 12.5, so it helps in preventing corrosion by reinforcement.
Okay.
And the coefficient of thermal expansion, our answer, I agree with that.
Okay. Thank you, Dr. Satish. Yes, the coefficient of thermal expansion of concrete, I'll write it, I'll try to write it here. Yeah. Yeah, the coefficient of thermal expansion of concrete is almost in the range of 7.4 into 10 to the power minus 6 per degree Celsius to 13 into 10 to the power minus 6 per degree Celsius. And the same for steel. The coefficient of thermal expansion for steel is in the range of 11 into 10 to the power minus 6 per degree Celsius to 12 into 10 to the power minus 6 per degree Celsius. So yeah, that is true. The coefficient of concrete and the coefficient of thermal expansion of concrete and steel are in the similar range. So that is a true statement. And also, the highly alkaline nature of concrete helps in preventing corrosion of embedded steel reinforcement. That is a true statement again, because we know that once the reserve alkalinity of the concrete gets consumed, that accelerates the corrosion of the steel reinforcement within the concrete. So, as long as the concrete is alkaline in nature, that will prevent the steel from getting corroded. So, these both of these are true statements. The question number 5 was compressive strength of concrete is typically more than its tensile strength. Can somebody answer that and tell me the relation between the compressive strength and the tensile strength, if it is true or not, and what is the relation between the compressive and tensile strength as per the codes? Yes. Okay, Shailendra, you can unmute yourself and answer.
Yes, sir. Sir,
Do you,
actually, yes, sir. The answer of this question is true. Compressive strength of concrete is typically more than its tensile strength because concrete is known for its compressive strength, and for the tensile strength, it is less in the tensile strength. Very
and
less.
can
Yes,
you
sir.
also tell the relation?
Sir, I don't have an exact relation, but
No, the relation that is given in the ICE code 456. Venki, you
sir,
want to answer it? Answer again. Okay, yes, yes, Shailendra.
sir, I have not an exact any relation,
Okay,
and
thank
I
you.
don't know, sir.
Okay, thank you. Venki, you can unmute yourself and speak. Your mic is already allowed. You have to unmute yourself to speak. No? Anybody else wants to answer this? Okay, this is a very generic or rather a trivia question for civil engineers. Yes, it is true. Compressive strength of concrete is typically more than that of tensile strength. And as per the IS 456, I mean, we generally don't calculate the tensile strength of concrete directly. So tensile strength of concrete is calculated indirectly either by split tensile strength of cylinders or by the flexural strength of concrete beams, plain concrete beams or prisms. And as per the IS 456, the relation between the indirect tensile strength, which is also referred to as the coefficient, the modulus of rupture. So FCR is equal to 0.7 root over of FCK, whereas where FCK is equal to characteristic compressive strength and FCR is the flexural strength or the indirect tensile strength. All right. Okay. Moving on to the next question. What inference can be made out about rusting of iron nail based on the following image? So the first image, in the first part of the image, it is shown that air and water is available, and the nail is dipped in water. In the first beaker, in the second beaker, the nail is dipped in a drying agent, so air is available, but there is no water. In the third beaker, there is boiling water, but no air. And in the fourth beaker, the nail is dipped in a salt solution. Let's assume it's a common salt solution, and the air and salt water is available to the nail. So, uh, what is the inference that can be made from this image about the rusting? Yes, Mr. Srinivas. You can unmute yourself and speak.
In the fourth case, the rusting will be at a faster pace, sir, because of the availability of air, water, as well as salt.
Okay. Okay. Great. And what else? And in the first three cases?
First case also, okay, air and water are available, so definitely rusting will take place. Whereas in other two cases, rusting may not take place, sir, because the available one thing is missing in both the cases. In first and fourth cases, corrosion is possible, but in the fourth case, it will be more severe because salts are also present. Chlorides.
Right. Right. Okay. Thank you. Anybody else wants to answer to that question? Add something to that? He has already rightly answered it. Dr. Satish again. Yes, Dr. Satish, you can unmute yourself and speak.
You see, air and water both are required for corrosion to proceed. So that is available in the case of first test tube.
Right.
Second tube, no air, so corrosion cannot proceed. In
Right.
third tube, no air, water is not present, so no corrosion is possible. In the fourth one, rate of corrosion will be the highest because salt accelerates. It's an electrolyte, corrosion rate will be higher.
Right. 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 Thank you so much. Yeah, so I have taken the help of a pictorial representation of the pitting corrosion process that takes place when chloride ions are present uh, in the concrete. So what essentially happens is that when so as already Mr. Srinivas and Dr. Satish have already pointed out that the rate of corrosion will be the highest when the electrolyte or the salt solution is present, and this is regarding that part of the question, that whenever chloride ions are present, so the chloride ions attack the passivating film of the that is present over the iron or the steel, the reinforcing steel or the metal, and this passivating film is actually generally made out of the oxidation of the metal, and it prevents it kind of protects the metal from corroding. So whenever chloride ions are present, after the passivating film is broken, these chloride ions can go and directly attack the metal. So what happens exactly is that when the pit is formed, in case of the pitting corrosion, the pit becomes an anode, and the surface of the metal becomes a cathode. So anodic reaction takes place, as you can see in this slide. Reaction takes place at the pit site, where the metal or the iron gets oxidized, and electrons are released. And at the cathodic site, at the surface of the metal, the oxygen that is available from the air, that gets reduced, and minus ions are produced. Now that the pit is formed, and in the pit the oxidation of iron is taking place, So it becomes highly positively charged. So now the chloride ions present in the concrete, they can move into the pit and they can form FeCl2, which is the I mean the metal ions can react with the chloride ions and form this FeCl2. Now this FeCl2 can dissolve in water, I mean hydrolyze in water, and that will form the corrosion product, that is FeOH, I mean whole thrice. That is the ferric oxide, that ferric hydroxide, that is the corrosion product that gets deposited over the metal. And due to this hydrolysis also, the acidicity of the pore solution increases because HCl is formed ultimately. So now that acidicity is I mean increased, so the chloride ions have a better chance of again attacking the metal, and that's how the pitting corrosion takes place. So at in a localized manner, the pits get formed and it deepens inside, and ultimately it corrodes the rebar, and the rebar is not structurally sufficient anymore to take the loads. So this is what essentially happens when chloride ions are present, either through ingress of chlorides from various external sources, or when chloride ions are present inside the concrete due to the admixed chlorides in the mixing water during the preparation of concrete. So that's how. So the point is that whenever you have a salt solution or a electrolyte present in the concrete pore solution, the corrosion rate gets accelerated. So the answer to this question, this has there are two answers correct. The first one is the air and water are required for corrosion of iron to occur, and presence of salt can increase the corrosion rate of iron. Right? Sorry. Okay. Let's move ahead to the next question. The seventh question was match the material properties with the definition. Hardness, material properties listed were hardness, elasticity, toughness, creep, strength, and there are certain definitions that are mentioned on the right hand side of the columns. So the first one was the ability of a material to absorb energy and plastically deform without fracturing. Let's go by what does it mean, and let's match it up to the material properties. So I'll start with the ability of a material to absorb energy and plastically deform without fracturing. Can somebody answer what is the material property that is being referred to here? Yes, Dr. Satish, if you want to answer. No?
Yeah. That is related to toughness.
Okay.
How much energy any material can absorb.
Right. Right.
Yeah.
Yes, so it is related to toughness. So in this so if I am drawing plot between the stress versus strain, and this is a typical graph of the deformation or the stress versus strain curve of, let's say, steel, mild steel, let's say. And uh, so here is where the fracture occurs, and if I draw a dotted line over here, and if I calculate the area under this curve, the total area under this curve will give me the toughness. That is the energy stored even after the plastic deformation. That is the total energy stored inside in the material. So that is known as toughness. The ability of a material to absorb energy and plastically deform without fracturing. So yeah, just before fracturing, whatever the energy is stored, that is known as toughness. The second material definition was the tendency of a solid material to move slowly or deform without fracturing. Anybody wants to answer that? Let's go to the third one per se. The ability of a material to resist plastic deformation, usually by indentation. Can somebody answer to the third one? What does it refer to? The material property that it is trying to refer to. Shailendra, you have raised your hand. You can unmute yourself and speak.
Yes, sir. This is a property of hardness.
Okay. Yes. So hardness is basically, I mean, if you might know, it is majorly measured by the Mohs scale of hardness. So basically, a harder material which is on the higher scale in the Mohs scale of hardness can produce a dent on the lesser hard material which has
Yes,
a
yes,
lower
yes,
Mohs
yes.
scale. So
It is also a abrasion resistance and
right.
scratch
So
proof.
right, that's what it is said that a harder material can abrade a lesser hard material, or it can
Yes.
produce a dent on its surface. So the ability of a material to resist. So I'll also start matching the
Sir, actually, what is the meaning of indentation?
indentation is
It is
producing a dent on the surface. So
that is penetration.
not penetration exactly, it produces a not exactly a scratch but a deformation or a depression, uh, anything that is different from the regular shape of the material, like you have dents on your cars whenever you hit your car or your bike or whatever your vehicle somewhere, it produces a dent on the surface of the vehicle, right? So
Yes.
that production of the dent, that process is known as indentation.
Okay.
So yeah, okay. The fourth one is the ability to oppose the deformation or breakdown of material in the presence of external forces or load. Yeah, anybody wants to answer this?
Yes, sir.
Yeah, Sharendra, go ahead.
Sir, it is strength of material.
Okay, that is the strength of the material, right? And what else is remaining? Okay, the fifth one is material returns to its original shape um, after having been stretched out or altered by force. Yes, can somebody answer to that? Uh, Mr. Srinivas has also raised his hand. I'll allow him to. Yeah, Mr. Srinivas, you can unmute yourself and speak.
It's the elasticity, sir.
It is elasticity, right? So basically, elasticity is again going to the stress strain curve. Before the elastic limit, whenever uh, material is stressed, this is stress and this is strain, and this is the elastic limit. This point is the elastic limit. So before the elastic limit, whenever a material is stressed, and once the stress is released, so this is the material is, let's say, and this is the strain that has occurred at this point of stress, and this is below the elastic limit. This is the sigma, and this is the strain. If the load is released, then it will come back without any dissipation of the energy. So uh, it will come back and retain its original shape without any deformation or any extension. So that is called as this property is known as elasticity. Having some disturbance. Yes. So that is elasticity. And the last one remaining is creep. So can somebody answer what is creep based on the definition that is already given? The tendency of a solid material to move slowly or deform without fracturing. Venki has again raised his hand. Yes, Venki, you can unmute yourself and speak. Dr. Satish, you can unmute yourself and speak. Venki,
Yes,
you have to unmute yourself before you speak. I'll give you a chance after Dr. Satish finishes. Yes, Dr.
yes.
Satish, go ahead.
It's definitely creep, time-dependent phenomena that is explained at serial number 2.
Right,
Tendency to move slowly, so it is time-dependent. This speed,
right,
whether it's slow or fast, so that is shown. So that is creep.
right, right. Thank you. Yes, Venki, if you want to venture a guess. No? Okay, yes, as Dr. Satish has already pointed out rightly. So the tendency of a material, solid material to move slowly. So it is a time-dependent phenomena, and creep is basically, so in the simplest terms, if I try to explain creep, even if the stress is constant, the deformation happens, and over time, even if the stress is constant, there is some kind of deformation that is going on in the solid, and that is known as creep. This is due to the viscoelastic behavior of the solid material. So, whenever a load is persistent on a solid material, it undergoes some kind of a deformation even without any increase in the load, and not instantaneously. This happens with time. So the answer to this question I have already marked here. 1 is matched with 3, 2 is matched with 5, 3 is matched with 1, 4 is matched with 2, and 5 is matched with 4. All right. Let's move ahead to the eighth question. Identify stresses A, B, C, and D acting in the structure depicted in the following figure. So I've already added the figure. Can somebody try to identify these stresses? I would like somebody else to answer other than Dr. Satish. I guess new people have also joined. Dharmendra, Suchita, if you guys want to answer, I can allow your mic. You can raise your hand. No? Balamani, if you want to answer, raise your hand. I'll answer. I'll allow your mic. Anil, Kiran, Manisha, Quadri, Suchita. Venki is just raising his hand, but I guess he has some issue with his mic, so he's not able to speak. Okay, Dharmendra has raised his hand. I've allowed your mic, Dharmendra. You can unmute yourself and speak.
Sir, stress A is
Right.
a tensile stress,
Okay.
uh, tensile. C will be compressive. D will be compressive.
Uh, you've said that A is tensile, B is
Yes.
B is
C will be compressive.
C is compressive, D is compressive. Okay.
Yeah.
And B, do you have any?
D will shear stress.
B is shear. And can you also tell me why A is tensile and there are, I mean, there have been three instances of A that are shown in this figure. So how
Yeah,
in each instance, how A is acting as a tensile load? Can you also tell me that?
it's a hogging moment, sir.
Hogging moment in which case?
Cantilever part.
The cantilever part on the left.
Yeah,
Yeah, okay.
yes, sir.
That is a hogging moment. So the extreme top fiber was going to have a tensile stress, right?
Yeah,
Okay. And in the middle portion,
it's a sagging moment. Yes.
the sagging moment. So again, the extreme bottom fiber is going to have a tensile stress. And in case of the moving loads,
Yeah,
which
moving.
is
Yes.
directly above the column or the pier, that
Mm.
there at the top fiber it is showing a tensile stress. Can you also tell me how?
Mm. Mm.
Okay, okay, let's leave that. Compressive stress.
Okay.
Let's come to compressive stresses again. C. There are two instances of C. Can you again tell me that? How is
Sorry, sir.
C, how is C compressive? Anybody else wants to take guess? Dharmendra, thank you. Dr. Satish, yes. Yes, Dr. Satish, go ahead. Unmute yourself and speak.
Please. In cantilever portion, top portion is tensile as already discussed. Lower portion has to be compressive because there
Right,
is contact fibers.
right,
Then to the middle one, it's just like a saucer plate-like situation. So top fiber is in compression, bottommost fibers will be in tension, and in between
right,
it has a neutral axis area. Then
right.
B is comprising of shear,
Hmm.
as shown by the figures also, very
Hmm.
well clear, vertical direction where shear stress is.
Okay.
Yes. D is compression.
D is compression. How?
The whole thing is getting compressed down below. So there is shortening of the length of this pier.
Right. So, yeah, as we know that piers or columns are compression members.
Yes.
So, ideally, they take the load from the beams or the deck in this case, and they pass it on to the footing or the foundation below. So,
Yes.
there will be compressive stress in the piers. And can you also tell me something related to the A stress shown just below the moving load, which is directly above the pier?
Yes. Yes. No, this free span will definitely have tension, but tension cannot stop altogether here. So there will be some transition area. So it will continue to be in tension, and then there will be change of profile. So it is deformation will be like this. Uh, One has tension at top, then this will continue like this, then there will be change of curvature. That's how tension will be there at the bottom in the mid region. So there will be
Okay,
transition.
okay. You're talking about propping due to the propped portion. I mean,
Uh,
due to the support. That's what you.
we have
That's
to go to
correct.
we
Okay,
have to
that's
go to
correct.
the deformation pattern.
Right, right, right. I got it. So
Yeah,
he's talking about the continuous supports case, wherein just above the
that's,
support, yeah,
that's it.
just above the support, the top fiber is in tensile stress, and the bottom fiber is compressive, and between the supports, it reverses. Okay,
That's it.
that I agree with that. But does it have any relation between the moving loads and the tensile stress? Okay, I'll help you over here. So whenever a moving load is, let's say this is a wheel rolling, right? So it has a velocity this way and it has a velocity this way, and the friction is acting in the opposite direction. So at the top fiber of the deck, due to this friction and the rolling velocity that is having the force that is I mean this neutralization of the force by the friction, so there will be a tensile stress um, at the at this moving load point, right? So this is rightly also showed, because as you also mentioned that again it is above the support, so it is going to have a tensile load, but this has a connection again with the moving load as well. So this is the friction part or the mu.
So due to the friction between the wheels and that will cause between the wheels and the deck, that will cause a tensile stress at the topmost fiber of the deck. And if you see that, interestingly, this moving load has directly been put in, I mean, just above the pier. So the weight of the load is going to be neutralized by the reaction itself. It is not going to be distributed anywhere else. The weight of the load, the weight of the moving load is directly going to be having a reaction from the bottom. So it is directly going to be distributed. So that won't create any kind of a moment as such. So the tensile stress over here is going to be due to the I mean, as he has already mentioned, due to the continuous support as well as due to the moving loads because of the friction component. And yeah, so everything is covered. So the answer to this question is A is tensile, B is shear, C is compressive, and D is again compressive. Okay. Okay, let's move ahead to the next question. Where do you expect flexural cracks in the cantilevered member shown in the following figure? Can somebody answer this question? Yes, Shailendra, you can unmute yourself and speak.
Yes, sir. At point A, there we can see the flexural cracks
Okay, and
due to
why?
bending.
Due to bending.
Yes, sir.
Why the flexural cracks are going to occur at point A and not anywhere else?
Because there is a actually the bending occur at the point A, and there is a reaction below the point A,
Okay.
support
So,
reaction that is not available anywhere else. So cracks will uh, happen at the point A.
no, the bending is occurring throughout the cantilever portion, not just at the point A.
Yes, sir.
But why will the crack appear at point A and not anywhere else in the body of the member? I mean, it might also happen somewhere else as well, but the first
Sir,
crack is expected
Yes,
to
sir.
have occur at point A. Why, sir?
maximum bending moment, sir.
Yes, thank you, Dharmendra. Maximum bending moment is at point A, and therefore, in a cantilever section, the so since the point load is over here, the maximum bending moment is at this portion, the point A, and the maximum since the maximum bending moment is at this portion, the top fibers are in tension and the bottom fibers are in compression. So, since this is a hogging kind of a behavior, and therefore the flexural cracks are going to occur at this position point. Since concrete is weak in tension, so the flexural cracks are going to occur at the top fiber. So on top of the member, close to the support. That is the correct answer. The 10th question is in the case shown in the following figure, when will the rope break? So this is a rope that is shown over here, and some person is trying to pull it apart. So tension is being provided, and there is expansion of the rope. And the question is, when will the rope break? And the options are tensile strength, when the tensile strength is greater than the tensile stress, shear stress is greater than the shear strength, tensile stress is greater than the tensile strength, either tensile strength is greater than tensile stress or shear stress is greater than shear strength. Which answer is correct?
Third one.
Okay, I have some issue. Just give me a
Third,
moment.
sir.
Yeah. Okay, Dharmendra, you were answering, right? Yeah, unmute yourself and speak again. Why is the third one correct? And why not the
Because
other?
if material strength
Mhm.
is tensile strength uh, increase at the
Right.
up, limit limit of the tensile strength.
Okay. Okay. And do you want to say anything about the shear stress, shear strength, whatever is written, whatever what other things are written? Mr. Srinivas, you want to say something? You are unmuted. No, it is not. Okay. Dr. Satish has raised his hand. You can unmute yourself and speak, sir.
Yes, this is basically a member in tension.
Right.
So when stresses exceed the capacity to take tension,
Hmm.
then it will fail. So third one is correct because
Right.
stresses are exceeding the permissible tensile stress.
Right. Thank you.
Yeah.
Yes, so since this is only a case of pure tension, there is no shear stress involved in this case. I mean, assuming that the rope is perfectly linear, so there is no shear stress involved in this case. And so whenever the applied stress, that is the applied tensile stress, exceeds the tensile strength of the rope or the material, that will be the case when the failure of the rope happens and the rope will break. So this is the question, and the correct answer is the third option. And the last question
Sir,
was more or
the
less.
tensile stress.
Yes,
Sir, I want to say something.
yes.
Sir, it is a induced stress, na? Tensile stress, it is induced stress, na? Due to applying the with the help of our hand, it is induced stress, na? Tensile
Stress
stress.
is always induced. Who is this? Dharmendra or
Sir,
Shailendra?
I, Sailendra.
Shailendra. Okay.
Yes, sir.
Yes, Shailendra. Stress is always induced. You cannot apply stress. You apply load, and
Yes,
stress
yes.
is reaction of the load.
Yes.
So the tensile load is being applied, and due to that, tensile stress arises in the planes of the material. And when this tensile stress exceeds the tensile strength of the material, that is when the material will break or failure will occur. Right?
Yes. That means, sir, both are the property of material only. Tensile strength and tensile stress.
No, tensile strength is the material property. Stress is the reaction. It is just like whenever you're applying a
Okay.
load to the beam and you get some reaction from the supports, right? It is exactly the
Yes,
same
sir.
way.
Yes.
You're applying some kind of a load, and that is where the internal reaction is the stress,
According to the load, stress will be produced.
right? However you vary the load, that will vary the stress as well, because stress is after all the
Yes.
load per unit area, and the unit area is assuming that the unit area is constant throughout the application of the stress duration, then the tensile strength will be directly proportional to the load, right?
Okay. Thank you, sir.
Okay, thank you. So the last question was more or less a funnier one. Just and so in this question, I'll ask you to tell me the analogy of this question to structures, to concrete structures and their durability. So the question was, which among the following is an example of routine condition assessment? Doing a blood test when sick, eating vitamins every day, doing a yearly eye checkup, taking bath daily. And what is the answer? And how is it analogous to the durability and repair of concrete structures? Mr. Srinivas, you have raised your hand. You can unmute yourself and speak.
So I'm not very sure, but for the question, it's a conditional assessment. So I feel it's like doing an yearly eye checkup, because for assessing anything, we have to do some tests and look at the parameters. And if there is any problem, then we have to go for the corrective action. So I feel the third option may be correct. I'm not sure.
Okay. Okay, thank you, Srinivas. Who else has raised their hands? Let me check. I had seen Balamani raise her hand. I have allowed your mic, Balamani. If you want to speak, you can unmute yourself and speak.
Sir,
Yes.
sir, I think the answer is the yearly eye checkup because when a structure is being there is any damage or something, we should give a repair, and for observation of the repair, we should take some time. So I
Okay.
think it will be a assessment period. So the yearly eye checkup will be it is equal to that.
Right. So, as she has already rightly pointed out, so repair is analogous to this, doing a blood test when sick. So, you find that the structure has deformed or has some high durability issues. It has deteriorated from its desirable state of application, and there you have to, like when you're sick you take a blood test there, when that's when you go and conduct some assessment of the structure, the durability assessment of the structure. You do carry out some tests and you assess how long the structure is going to remain in its service life, and will it work, will it continue to provide a service for the desired life or not, and then only will be doing carrying out the repair work. If the structure is sick, then the repair work is carried out. Again, eating vitamins every day and taking baths daily are not very practical in the case of structure. Like you can't carry out repair work, or you can't just carry out some testing work of the structure daily. That is not practical, and that is not economical as well. So this is ruled out, not economical, not practical. But what you can do is you can take up a routine assessment of the structure's health. So that is in that it is a rather recent advancement in the field of civil engineering is what we mention as structural health monitoring. That is how you there are some I mean that is a whole another field of civil engineering wherein you put some sensors and in the structures and you try to assess the deformation that is being taking place in the structure due to the loads and the kind of performance that the structure is providing. So that is a routine health checkup for the structure. Also, health monitoring. Yeah. Structural health monitoring is kind of the routine assessment of structures. Apart from that, you can also check now and then that if the structure is performing well, you can carry out some tests. If you're having some seepage or any kind of issues that might have an effect directly on the durability and the strength of the structure, then you need to restrict that. You need to assess that and restrict it in the best possible way. So yeah, so this is kind of an analogous question from our day-to-day life to the durability and repair of concrete structures. And that was the last question of this assignment. The reason why I have not discussed I guess some of you were not present during the initial introduction of this session. I guess the reason why I have not discussed the week one's assignment is that the deadline of submission of that assignment is 8th of February, and so after that only we'll be able to discuss that assignment. I guess both week one and week two assignment, the deadline is 8th of February. So possibly we might take up both of the assignments in the next class. But apart from this, in the today's session, so we have some time left. If anybody of you have any questions, you can raise your hands. I'll allow your mic and we can discuss. If you also have any questions related to this session, we can also take up that now. Yes, Shalendra. Shalendra, you can unmute yourself.
Yes, sir. Thank you, sir. Sir, I have question regarding question number 6.
Okay.
Can you open it?
Sure.
The file.
Question number 6. Yeah. Yes, tell me.
Yes, yes. Yes, sir, I don't understand what is being given and how we can answer this.
So the question actually asked us that in this image there are four possible scenarios that have been shown. In the first scenario, there's a iron nail which is dipped in water and which is open to
Yes, sir.
air. So both oxygen and water are available to the nail. Again, in the
Yes, sir.
second case, there is no water, but air is available. In the third case, there is water available, but no air is available. And in the fourth case, both air and water are available, as well as an electrolyte or a salt uh, is present in the water. It's a instead of normal water, it is a salt solution. And the question was,
Okay, sir.
uh, the options were like air and water are required for corrosion, and the third was presence of salt can increase the corrosion rate. So the in this slide, what I explained was. Yes, of course, both air and water are required for corrosion to take place, for corrosion of iron to take
Yes,
place.
yes.
But when salt solution is present, so that will accelerate the rate of corrosion. And the
Yes, sir.
mechanism that I explained was this. So that is there is a localized anode and cathode formed, and due to that, the pitting corrosion occurs in case of the presence of chlorides. And so in that particular location the a pit is formed, and the that pit grows in size and it renders the reinforcement unserviceable, right?
Yes, sir. Yes.
Do you have any more doubts?
No, sir. Sir, please show me the options regarding this question.
Okay, the options were this: air and water are required for corrosion of iron to occur. Only water and salt are required. That is wrong because air is also required. The second option is wrong. Presence of salt can increase corrosion rate of iron. That is true. Water, air, and salt are required for corrosion of iron to occur. I guess the third
Sir, it is
option.
also true. Last one.
The last option is also correct, I guess. Yes, I have missed it.
Yes, sir.
No, 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 no. It is not required. Sorry,
Yes.
that this is wrong. Salt is not required for corrosion to occur. Only water and air are sufficient for corrosion to occur. Salt will accelerate the process. So this is also wrong. It is not. It is not a requirement. Salt is not a
Okay.
requirement for corrosion to occur. Anyway, without salt also the corrosion might occur if both water and air are present. So the basic requirement for corrosion to occur is air and water. So the presence of salt will just accelerate.
Okay, sir. This is
That's
the
in. I mean, you
yes, sir.
in the
Last one
due
is the
course of this.
main point of confusion, sir. For me.
Okay, okay. Yeah, right. Thank you. Thank you for highlighting it. Yeah, during the this course also you will learn about carbonation induced corrosion and both corrosion due to chloride influence. So in that case, in the case of carbonation induced corrosion, there is no presence of, I mean, the presence of salt is not required for that kind of a corrosion, right? So yeah, you'll learn
It is
it in
like
the,
catalyst, sir. Only accelerate the
yeah,
neutron reaction.
that has a catalytic behavior.
Yes, sir.
Okay, thank you. Do you have any more questions?
No, sir.
Okay, thank you. Anybody else has any questions or any feedback, any discussion that you want to have in this session? Yes, Dr. Satish, go ahead.
Uh, it was wonderful interaction. You
Thank you.
had
Thank you.
tried to cover everything in a very nice manner. I think it is understandable to all the participants. Thank you.
Okay, thank you. Thank you so much, Dr. Satish. So it was more of a feedback or compliment. Thank you. Yes, Shailendra, you want to speak something again? Yeah, go ahead.
Yes, sir. In a question where we have to find the type of stress, tensile, compressive,
Right.
or it is
Question number
shear.
8.
So in this question, what will happen if yes, sir, this is what will happen if the moving loads is on the cantilever type beam?
Cantilever type beam? Okay, the cantilever portion.
Yes,
Yeah,
sir.
again, see, so
Yes, sir.
if
Yes,
the
sir.
moving load is at the cantilever portion, let's assuming this. So in the cantilever
Yes.
portion, what is the type of deformation that is occurring? It is right. It is like this, right?
Yes, sir.
So the top portion is already having a tensile stress due to the loads, due to the vertical loads, and the bottom
Yes.
portion is having a compressive stress due to the vertical loads, and due to the moving load that I already mentioned, again that will have a tensile stress. So the tensile stress at this portion will increase due to the moving loads.
Okay.
Okay.
Yes, sir. It will be the same case, but the tensile stress will be increased in case
Will
of
be more
moving loads.
yeah, will be more than in the first case without the moving.
Okay, sir.
Okay. All
Thank you, sir.
right. Thank you. Anybody else have any questions?
Sir, when next meeting will schedule? Or
uh, this session, I mean the session that is taken by me will be occurring every week from 6 p.m. to 8 p.m. on Saturday, right? And
okay.
there is another teaching assistant for this course as well. His name is Umesh. You might have also gotten the link for his session. He takes the session on Fridays from 7 to 9 p.m.
Okay, yes, sir.
Okay. In case
Thank you, sir.
some of you were not present during the introduction of this session is going to be uploaded on YouTube as well. So you will be provided with that link also, and you can log into that link and check out the session again if you want. Yes, Dr. Satish.
Yesterday there was a message for session between 7 to 9 p.m. But actually it was not held. I tried repeatedly for 1 hour. I don't know what
Okay.
was the problem. Message had come, link had come,
Mhm.
but nothing happened. Nothing happened.
Okay. I'm sure that he would have taken the session, but there might have been some kind of a technical issue. I'll also get in touch with him, but
Yeah,
I'll recommend that it is a better way that you raise this issue yourself or through the NPTEL course, so
yeah.
that the concerned TA will take this issue into consideration, and yeah, from the next time onwards, that this the session will go smoother.
Because I tried for about 1 hour. I thought
Okay,
that there's something
what
wrong
is
at
the
my
issue
end.
exactly?
Nothing happened. There was no connectivity.
Oh,
So
okay.
host will allow you in, but never allowed. So it appears
Oh,
that
okay. The issue would have been like yeah, with the settings of the meeting, he might have kept it to allow each of the guests individually. So that's
but
why.
probably what I understand is probably there was no session yesterday. Otherwise, there was no reason.
Okay. No, I'm pretty sure that the session was conducted, but anyway, there might have been some kind of a technical issue either on your side or on the side of the TA. I'll inform the TA from my side, but I also
Yeah.
recommend that you raise this issue from your end through the NPTEL portal so that
Okay.
yeah, the TA will be informed regarding this.
Okay.
Thank you, Dr. Satish. Yes, Dharmendra.
Sir, any reference book for this
I guess the
for
reference books have already been listed in this SWAYAM NPTEL portal.
okay,
Yeah, you
okay,
have to check it
okay, sir.
there.
Okay, sir. Thank you, sir.
Yes, Sharendra.
Sir, actually, during the joining of this course, I have joined another courses of the same name, but I don't want to going on with that course. So what we have to do, sir? We have to leave it or we have to
Uh,
close it
so,
from somewhere
Shailendra,
else.
I inform you that I'm only the teaching assistant for this course. Neither am an employee of NPTEL nor am in any way concerned with the proceedings of the NPTEL courses. I just have to take the sessions and clarify your doubts for this course alone. So, I will not be able to help you regarding the doubts that you're having regarding any other course. But I'll suggest you that you can raise this issue with the NPTEL team. You can mail them, and they'll probably provide you the right help.
Sir, yes, I have already mailed but not received
Okay, but
any reply
sorry,
from.
I will not be able to help you regarding that.
Uh,
I'm
should I
in no way
reply to
concerned.
this question? Should I reply to this question?
Yeah, yeah, sure, sure, Satya, Dr. Satish.
Uh, you can appear for a number of courses. If you are not prepared for the other course, if you don't appear, they don't provide you with a certificate. You can appear for more than one courses also. Many people do number of courses in one semester. So NPTEL has no objection. If you write the exam, very good, they will provide a certificate in case you qualify. If you don't write, then you can get the education. That's all.
Right, right.
So
Okay.
nobody stops you from registering or appearing in exam. For appearing, there is some last date and you have to submit some fees, etc. Otherwise, joining courses is not a problem. Anybody can join.
Okay. Thank you, Dr. Satish, for responding to this
I
question.
happen to be
Okay.
NPTEL star, so I have done number of courses. I am in a position to reply. The gentleman
Okay.
can ask if he has some doubts.
Okay. Yeah, Shailendra, the best way is to contact the NPTEL team. They'll surely help you out, whatever the issue you're having with the NPTEL courses. Okay. And
Okay, sir.
thank you, Dr. Satish, for
Okay,
responding
sir.
to that question.
Thank you, sir.
Okay. Anybody else have any doubts or feedback or discussion?
Sir, can we get this PPT for the future reference?
Yes. So what I'll suggest is um, I cannot directly give you the PPTs. The way through to I mean the way for you to reach to the PPTs through NPTEL only. So I will be uploading the all the course content and the lectures as well. The link, everything will be uploaded to a shared folder with the NPTEL, and NPTEL will in due course will share it with you probably. Okay.
Okay, sir.
Thank you.
Thank you, sir,
Okay.
for providing this valuable.
Sure. Okay, we'll have this meeting continue till 8 p.m. I am muting my mic for now. In case you have any issue or any doubts or anything regarding this session or the course of durability and repair of concrete structures, you can raise your hand in this meeting and I'll attend to your question, your query. Okay, thank you. Yes, Dr. Satish, you want to say something? Oh, sorry. I'll allow your mic. Wait. Yeah, you can unmute yourself now. Dr. Satish, you can unmute yourself and speak.
Uh, can we leave now?
Yeah, you guys are free to leave. I mean, if you don't have any more questions, you can leave.
Oh, thank you, sir.
Yeah, thank you. Yeah, the session is over for now. Unless you guys have any other questions, I mean, you can stay. Otherwise, you can leave. Yes, Balamani, I have allowed your mic. You can unmute yourself and speak.
Sir, I have one doubt, sir.
Yeah.
Actually, in your first lecture, you have shown some, apartment or something, in in which you have shown some that there is a, the clothes were in the balcony. The clothes were being hanging, due to which there is some corrosion in that balcony areas.
Okay. Okay.
Sir, actually, even you told that
No,
they
I
will be
didn't. So
repairing.
I'll correct you first of all. I don't take the lectures. The lecture is taken by Professor Radhakrishna G. Pillai. So
Okay, okay,
yeah,
sir.
the content is different. But yeah, if you have any questions, you can ask me. Yeah, go ahead.
Okay, sir. Actually, that he was telling that repair was done in it is how to say, in a just for the time they have just repairing with a patchwork, and they are leaving that the same cracking again and again. But but what is the remedial measures for that? If there is any corrosion again there is some water leakaging or some dampness is there,
Mm-hmm.
what are the remedial measures for that area, sir? But we cannot stop the people from doing the same thing.
Right, right.
So, is there any other structural wise remedial measures on this, sir?
There are a lot of remedial measures as when so whenever water is available to the concrete directly, even though it is good for curing purpose, but for a aged concrete, whenever water is available and air is freely available, it will kind of facilitate the corrosion process, provided depending on what is the type of corrosion that is taking place. But I mean, depending on if it is a carbonation induced corrosion, which is quite not likely, unlikely because it is a long process to take place. So it is a unlikely case, but the corrosion can also happen due to chloride induced corrosion, right? And these chlorides can get inside the concrete due to the water that is being supplied. As you already mentioned that there is seepage or any kind of water available on the surface of the concrete. So the first way is to prevent allowing the seepage of that water into the concrete. For that, you can since the structure is already constructed, you can apply some waterproofing compounds over the concrete surface so as to restrict the water from entering inside the concrete. But if there are cracks already happening inside the concrete, then you have to close the cracks as soon as possible. But before closing the cracks, you have to repair those cracks. But before repairing the cracks, you have to check that if the steel that is, inside the concrete, has it started corroding? If it has already started if it has already started corroding, then there is no point in repairing the cracks alone, because anyway if uh, if corrosion has already started, it will proceed even if you seal the cracks. So that is the kind of measures that you have to take to restrict the corrosion in that kind of a case, right?
Okay, sir. Okay, sir. Thank you. And one more question, sir.
Yes.
Sir, actually, in one another slide, he was showing regarding the carbonation of the bridges near that traffic areas. So whether there is a direct sunlight, there will be that carbonation will be, I think, less, and beneath the, bridges, the carbonation will be more. Under the easily, there will be during the periods, the corrosion will be starting at that areas under the beneath the bridges. And
Beneath,
whether is there any beneath the bridges, bottom of the bridges,
right?
because that area the sunlight was not there. So the maybe he told that the corrosion will be at that area point of first. The corrosion will be starting at that point only due to the time period. And he also shown that some repair works over under the bridge areas where the corrosion has been taken place. And during that corrosion period, we will see any. Uh, we'll see any reflection on the top of the bridges or any symptoms on the top of the bridges. I mean, like cracks or something, that so that we understand there is a corrosion in the steel in the bottom.
Okay.
I mean, are you
I'm not.
getting my point, sir?
No, I'm not sure actually what you're speaking about. Can you tell me the lecture number or anything so that if I happen to look at that lecture, I'll get back to your question in the next session.
Just a second, sir.
Yeah.
Sir,
Yes.
sir, it is in the carbonation induced corrosion slides.
Okay.
I think it is a type of location where carbonation induced corrosion can occur. That slides.
Okay. Fine. So he told you
Uh,
that. So this is in the week one lecture, Malamni. Are you there?
yes, sir.
Yeah.
It's a week one lecture. Week one lecture.
Week one lecture. Okay. I'll look at it again. But anyway, if it
Okay.
is carbonation induced corrosion, so basically the process of carbonation induced corrosion is such that if the concrete, so let's say there is no concrete around the steel, and the steel
Okay.
is directly dipped in water and air is available, it will get
Mm.
corroded right away, right? But whenever
Yes,
there
sir.
is concrete around the steel, so first of all, for corrosion to happen, the water has to penetrate and the
Correct.
oxygen has to penetrate to the site of steel, right?
Mm.
And
Yes, sir. Yes,
as
sir.
such, steel and carbon dioxide itself are not very soluble in water. So,
Yes, sir.
so what might be the reason is that when the pier is submerged within the water, the concrete pores are saturated, and when it is saturated, the ingress of carbon dioxide is limited. The solubility of Because the solubility of carbon dioxide in water is limited, it's less. So that's why carbonation is less likely to occur for areas of concrete which are submerged within the water.
Okay. Sir, what
And
about
since
the bridges
carbonation
near the?
cannot happen, so that will also restrict the corrosion as well due to carbonation.
Sir, this is near that fire area. Sir, what about the bridges near that? Traffic areas.
Bridges
If
near
that
the
the traffic.
traffic areas, isn't? What did he say in that? Again, I'll have a look at the lecture. I'm not sure exactly what you're talking about. If you had been able to explain it in a better way, I would have answered you to a question. But I'll take this
Okay.
time. I'll look at the lecture again and I'll get back to your question. I've noted it down. I'll get back to your question in the next session.
Okay, just I want to know if the bridges, I mean, the steel under the bridges is getting corroded. What are
Mhm.
the symptoms or indication it will show on the top of the bridge or any sides of the bridge? We know that it is corroded.
Okay.
Actually, he
Yeah.
told the
So
pipe
in
most
any kind
mostly.
of a structure which has a reinforcing steel inside it, and if the steel has already started corroding, so the corrosion products get deposited over the steel. And when the corrosion products get deposited over the steel, they have a larger volume. So the volume of the steel, the volume within the concrete is trying to expand. It's tending to expand. So since the concrete is having an expansion from within, it will have tensile stresses inside it, and due to the tensile stresses, it will have cracks on the surface. So whenever you have a corrosion, the best way to assess if it is a corrosion, I mean, if corrosion has already occurred or not, is to look out for cracks on the concrete surface in any case, in any
So,
kind of a structure.
so this is for both for normal steel and both for pretensioned also.
No, I'm talking about reinforcing steel. I'm,
Okay,
I'm,
sir.
I'm
Okay.
talking about normal RCC structures.
What about that pretensions, pre-stress?
What exactly do you want to ask about pre-stressed concrete? Like the corrosion in
Actually, not.
pre-stress?
Yes, sir. Corrosion priest.
Okay. Um, I, I don't feel there is a very, I mean, any particular difference in the case of corrosion in the process of corrosion mechanism in RCC structures and pre-stress structures. But the basic difference is in the principle of how the RCC structures and how the pre-stress structures work. So the basically, whenever you are having a pre-stress structure, it is already stressed somehow. So if since the pre-stress structures are already having a compressive stress, even though the steel has corroded and you're having a tensile stress within, that tensile stress has to nullify the already applied compressive stress first, and then only the cracks will appear on the pre-stressed structures. So I don't think there is any difference in the mechanism of corrosion between the RCC and pre-stressed structures, but the difference lies in probably the principle of how RCC and pre-stressed structures work.
Okay, sir. Okay. Okay, sir. Thank you.
Yeah. Anyway, I'll get back to you with a better answer next time in the next session. Okay.
Sure.
I'll look at the
Sure,
lectures
sir.
and
Thank
I'll
you, sir.
get.
Sure, sir. Thank you, sir. Thank you. Shall I leave, sir?
Yeah. Yeah. Sure. Sure. Thank you. Dharmendra, you want to say something? You had raised your hand. You can unmute yourself and speak. All right, since you have no more questions, we are closing the session for today, and we'll see you next week on Saturday from 6 p.m. to 8 p.m. again, and and we'll be discussing the doubts from the week 2 lectures, as well as we'll be taking up the week 1 and week 2 assignment questions. Okay, thank you all. I'm closing the meeting for now.